Hey, if you're watching this, you have probably seen a ton of TYS solutions. But here's the problem. Most 10-year series video solutions just show you the answer, so you don't know what the questions are testing for. Instead, in this video, I'm going to break it down step by step so you actually understand what concept the question is asking for and how to solve it so that you earn every single mark. Hi guys, I'm Singy, a former RA student and RA coach, and I have taught 500 plus students with 80% scorings A1s and A2s. Here's the topical breakdown for every single question, and all in all, we have 37% which consists of algebra, 31% with geometry, 17% for arithmetic, and then last but not least, 15% for statistics. Let's take a look at question 1 now. Alright, so we have a question on algebraic simplification. Alright, and it's a very encouraging start because we just need to simplify the terms. We are given terms that consist of either y's or the numbers, right? So all we have to do is to rearrange and put all the like terms together. So it looks like this. I can put my 3y minus 5y plus 4y, and then minus 7 plus 4 minus 2. Okay, and then simplifying the terms together, we will get a 2y minus 5 as our final answer. And we are good to go already for question 1. Okay, moving on to question 2 is a question on inequality number line. And this question gave us the number line, and we are supposed to derive the number line instead. So over here, you can see that the numbers, the two terms are sticking together. Right, this line over here. So let's take a look at what this line represents first. We have the empty circle over here, which represents less than or more than without the line below, which means I will not include the number. Okay, that is below over here. While the shaded circle over here, okay, it means less than or equals to, and that means I have to include the number. So let's look at each of them one by one first. The first one, okay, it's when x is more than, so can you see that this line is going towards the positive side. X has to be more than negative 1.5 without the line below. And the second one right here, we have x being less than or equals to 8. So we can merge these two together, and we must merge these two together because this is one line over here, and that gives us minus 1.5 to 8 inclusive of 8. Moving on to question 3 is a question on hire purchase. Hire purchase is a mini segment that does not come out every single year, okay, but of course it's something that is important for you to understand. All right, it may come out again this year for O levels, right? So let's take a look at the question together. We have the cash price of a garden fountain to be $2,250, and Arman buys the fountain using hire purchase. She pays a deposit of 18% of the cash price plus 24 equal monthly payments of $92.75. Calculate the total amount that Arman pays for the fountain. So let's first run through what is hire purchase. Hire purchase happens when you are not paying everything upfront. So in this case, Arman is not paying the fountain upfront, but instead, she's going to pay a percentage first, which is the deposit. Once she pays the deposit, she can already bring the fountain home. But over the next 24 months, she has to actually pay a monthly payment to the shop. Okay? And after the 24 months is up, then she has officially owned this fountain. Yay! Alright, so over here, let's go back to the question again. Calculate the total amount that Arman pays for the fountain. So we have to include the deposit, which is 18% of the cash price, and the monthly payments, which is 24 months of this, right? So let's put them together. 18% of the cash price and 24 months of $92.75, which gives us $2,600. $631. And part B wants us to calculate the extra cost of using hire purchase as a percentage of the cash price. So whenever we deal with percentage questions like this, we need to ask ourselves where's the numerator and denominator being placed for percentage. And one very good way to think about is what is before the word as a percentage of, and what's the word after. So in this case, extra cost was the one being placed before, cash price was the one being placed after. So if you follow this for such percentage questions, right, you should be okay already. And then we can start filling in the numbers, right? So extra cost, we have 2,631 minus 2,250, and then we divide by 2,250 times 100%, and we will have a 16.9% for part B. Question 4 is on box and whiskers plot. They give us a box and whiskers plot. So there's a lot of interpreting of data over here. You'll realize, like the first one, we also need to interpret an inequality line. Now we need to interpret a box and whiskers plot. Okay, so do expect a lot more of this kind of interpretation rather than you getting to draw the box and whiskers plot. So they want us to find the median time first. So let's revise on box and whiskers plot. What does every feature of this entire thing represent? So number one, all vertical lines represent a particular data, right? The very first one is the smallest value you have in the data, the minimum. So in this case, looking at the scale, 6.5 is the lowest number of hours. Wow. Okay, the highest number of hours is 31.5 hours. And we still have 3 vertical lines here, right? So number 1, I have my lower quartile. 2, I have my median. 3, I have my upper quartile. So of course, you don't have to go and identify all of it during the exam. I just want to show you what the data represents. The question is now only asking for median time, right? So the median time, check the scale properly first. Median time is over here, and that is 15.5 hours. Okay, so that's for part A. So moving on to part B. Okay, this person says, Rishi, there are almost twice as many adults who spend more than 20 hours on social media as there are adults who spend less than 12.5 hours. Is he correct? Give a reason for your answer. So then it goes back to the question of, do you understand the box and whisker plot fully? When you look at a box and whisker plot, the length right here does not represent the actual number of people. This x-axis right here represents the time in hours. So how can we say that this is the number of people? This is double of this, right? Because they say, Rishi says the people who's more than 20 hours is twice of the less than 12.5 hours, right? So let's recap on lower quartile again. Lower quartile is 25% of your frequency. It's the 25th percentile of your number of people. So that's one. Secondly, median is 50% of your frequency. And of course, building up, upper quartile is 75% of your frequency. So when you have all of this, that also means that on the other hand, because this is the entire data, this is 25%. Which means, okay, going back to this, let me draw out first. Going back to this, we can straight away determine that the value that is less than 12.5 and more than 20 hours, these two are actually the same because both of them are 25% of the entire population of adults that we have interviewed. Okay, so that's what we can say. Rishi is incorrect because 20 hours represents the upper quartile and 12.5 hours represents the lower quartile, which means there is an equal number of adults who spend more than 20 hours and less than 12.5 hours on social media. Next up, we have question 5 on algebraic fractions, subtraction, mainly subtraction, right? So expressed as a single fraction in its simplest form, this entire thing. So there are two things I always look out for: the denominators, all right? So these three over here, and number 2, what are the signs in between? Why do we want to do that? Because the very first thing we want to do is to make them the same denominator. So for my first fraction, I multiply by 4 to get to a 24. It's the LCM. 8, the second one, 8, I'm going to multiply by 3, So the very first step is making all the denominators the same, and then we can combine them after that. So with this, I will be able to get 28x as the numerator, and 9 times x plus 1 as the numerator over here. We don't have to touch this third fraction at all. Now let's begin combining all of them into one, and we must be extremely careful with the negative signs. So right here, this is how I put them together, and notice one thing: I actually kept the bracket here and I actually added a bracket over here. This is essential, especially, okay, in this case when you have to remind yourself that you have not included the minus sign into this bracket yet. Okay, and then upon adding this negative sign inside over here, now we can open up, okay, because we have invited them in, right? So we open the door already. So please remove the bracket. So the bracket is a very good way to signal to yourself, have you invited the minus sign in? Only minus signs. Plus itself it doesn't change the sign. So that's why I always tell my students, please, when you see a negative sign, just slow down a little bit, be extra careful, okay, of what's going to come after. And that's when we can put them together for the numerator part in the simplification, in terms of the simplification aspect. Now, one last thing for all algebraic fraction. One very important thing I need you to do is to check the terms, okay, to see if they are fully simplified. Okay, so looking at these 3 terms, there's actually one more thing we can do. 12, 3 and 24, all 3 can be divided by 3, and you have to ensure it's every single term. Then you are allowed to do this. If it only affects some terms, please do not do it. Just keep the fraction as it is. Okay, so that's something you really have to look into when you're looking at simplifying fractions. Moving on, we have skills and maps question. Alright, so question 6 says a map of Singapore has a scale of 1:200,000, and part A says the scale can be written in the form of 1 cm is to n km. Find the value of n. So right here, when they give us a scale like this, always treat both sides as in centimeters. Okay, when they don't give you anything, both sides are in centimeters unless stated otherwise. So now the question is, how am I going to convert centimeters to km over here? So let's recap a little bit. Cm, 2 meters, is a division by 100. Meters to km is a division by 1000. So we can do it step by step. You don't have to jump from cm to km. Okay, so 200,000 cm to meters is 2000. I divided by 100. And then 2000 meters to km is 2 km right here. So I have n equals to 2 as our final answer. Moving on to part B. The distance on the map from Changi Airport to Bukit Panjang is 18.9 centimeters, and calculate the actual distance in kilometers between these two places. So usually we can use the answer from part A to help us. Reason being, the actual distance they now want us to find is in km. So if you are starting from 1:200,000 cm again, you're actually going a step backwards again. So make use of part A's answer. 1 cm on the map represents 2 km on actual ground. So just take your 18.9 cm and scale it up times 2 to get 37.8 kilometers for the length from Changi Airport to Bukit Panjang, the actual length. And then we have part C, a very common flow as you can see for scales and maps. Firstly, they like to ask for maybe a changing of the scale. Secondly, they will give you some sort of length, maybe map length convert to actual, or the actual length convert to the maps one. But ultimately, after that, part C, usually they will scale it up to area. So part C says the area of Singapore is 728.6 kilometers square. Calculate the area in square centimeters of Singapore on the map. So once again, which scale is better for me to use? So that's when you have to ask yourself, how do we even convert to an area scale first? Okay, the length scale currently is 1 centimeters to 2 kilometers, right? And my area scale is always squaring both sides. And one super important thing is always choose the one that is easier to square. And most of the time, I would rather square the one with the higher units, all right, which is the one from part A. 1 cm square is to 2 km square. Why? Because your question already gave you this in km square. So why you want to go and square your 200,000 cm? And when you go and square 200,000 cm, you can go and type inside your calculator. It's going to be crazy, man. The number is going to be very crazy. So I rather square 2 than 200,000. Okay, so I have a 1 cm square to 4 km square here. And since we are given the actual area, convert it to the map by taking 728.6 divided by 4. Now I have 182.15 cm square. Question 7 has two parts of factorization. The very first part is a very direct, taking a common factor out of each term. Okay, because I have 18a minus 24b plus 15c, they don't have much in common. The only thing they have in common is the 3 numbers in front. Okay, so don't need to think too much for this. I just need to take out 3, and I have 6a minus 8b plus 5c as my final answer for part A. Part B requires a bit more effort because we see 4 terms right now, right? And for 4 terms, most of the time we will likely turn to grouping technique. Okay, students, so take note, whenever for this kind of 4 terms itself, right, you either do it in a pair situation, 2 by 2, okay, sometimes even in a 3-1 situation. All right, so we will usually turn to grouping technique itself. How do we do grouping technique? Okay, let's look at it together. So the very first thing is we got to pair them up. We're going to find the right pair. And in order to find the right pair, we have to look at what are the common factors the pairs have. So I decided to group 3 minus 3mx together and 2m square xy with minus 2my together. And the reason is because we want to have common terms, right? So between the first 2, we know there's a common term of 3. Between the next 2, we have a common term of 2my. Okay, so let's recap. What do we need for grouping technique? We need to make sure these 2 brackets are the same, right? So let's observe these 2. What do you see? 1 minus mx and mx minus 1. I call this the same but different. I always tell my students that. So what's same but different? They are similar in terms of the term. I have a 1, I have a mx over here. But why are they different? Because one is a positive 1, the other one is a negative 1. One is a negative mx, the other one is a positive mx. Okay, which means we can't continue with grouping technique at this point. We have to do something else first. Okay, and that is your changing sign technique. So one way to think about it is you are actually substituting or factorizing out negative 1 out from these two terms. And after taking negative 1 out, that's when I will be able to change the sign of this blue. Negative mx, negative 1, we will be able to change it to positive 1. And ta-da! See, we will have two of the same terms already. Now we can finally get 1 minus mx out and leave your remaining terms of 3 minus 2my inside. And that is your final answer. Moving on to question 8. Okay, we have a very interesting sequences question for the 2024 paper. They gave us this over here, and they say the difference between any two consecutive terms is the same number. So of course we know it will be the same difference. Okay, so they gave us two value. One is the 15. One is the sum of all these terms is 105. Okay, but we have a problem. The problem with this question is that there are too many unknowns, right? How can we find w, x, y, z using, algebra if we want to combine all of them together? So we have to think about, is there a way for me to reduce the number of unknowns? Okay, in order to solve this question. So the very first thing is we're going to let the common difference be d. And then you may be thinking, another unknown? That aren't we making things harder for ourselves? Okay, so let me explain. When you include this d, okay, of course it's going to represent here plus d, plus d, plus d, plus d, right? Why do we want to do that? It's because we have this number over here which allows us to say that w plus d gives us a 15. Okay, you may not be able to see the full picture yet, but let's move on to the next part first. Because of this, I can also create x, y, z in the same form. X will be equals to w plus 2d. Y will be w plus 3d. And z equals to w plus 4d. So what do you realize now? We will be able to change each term and be able to add all of them up to get 105 here. And because of that, we created two equations with two unknowns. That's good news, right? So let's continue our solving right here. So w plus d is equal to 15. And over here, because we have two equations, right, you can either use your substitution method or elimination, up to you, right? I decided to use substitution method right here, making d the subject. So d equals to 15 minus w, that's equation 1. Alright, and then we have 5w plus 10d equals to 105, which can be reduced. So I reduce it to w plus 2d equals to 21. This is equation 2. And with this two, I'll be able to sub in to get my w to be equals to 9. And you can easily just bring it back to any equations you like to solve for d equals to 6. Okay, so you can just sub into here, or you want to sub into here, also can. And we have it ready. We already have w equals to 9. And we know x is 2d plus another 2d, right? So it gives us 21. And then for y itself and z is going to be 27 and 33 respectively. Let's move on to question 9 on area of sector. Right, so in the diagram, the shaded area represents the area claimed by a windscreen wiper, and all lengths are in centimeters. Okay, so the shaded area is over here. Calculate the shaded area. So as you look at this diagram, take a look at what is given to you first. We have this big sector here, and I hope you also notice this small sector over here. So usually a sector is part of a circle, right? So you can imagine there's a huge circle going around this way, and there's a mini circle circling around this way, and we are given the radius of the small circle and the radius of the big circle, as well as the angles in degrees. Okay, so this is extremely important, because if the angles is in degrees, that means you have two choices. Either you want to change your angle from degree to radian first, then you use the formula sheet area of sector formula, or you can do it in my way. Currently, since it's already in degree mode, I decided to find the portion, okay, the proportion of the sector, which is 96% over 360 percent. Sorry about that. Okay, 96 degrees over 360 degrees, multiply with pi r square. So that will be the circle over here. Same for this. Take the proportion, then multiply by pi r square, which is the area of circle of the small one, and you should get 6,303.29. Okay, and then corrected to 3SF is going to be 6,300 square centimeters. Moving on to question 10, we have our trigonometry right here. So we are given this diagram. Okay, and when on first look, okay, we have all this information over here, and more importantly, I hope you guys notice this right angle triangle, because the very first thing they're going to ask us is calculate the distance AC. Okay, and when it comes to right angle triangles, I usually just think about two things, and you should too. You should only think about two things: Tuakaso or Pythagoras theorem. So in this case, we are going to think about Tuakaso. Okay, and why is that so? From here, we already have the angle, and AC is the opposite. So I can actually use my opposite as well as the hypotenuse here. So opposite and hypotenuse will put together to your SO. So sine 58 degrees is equals to AC over 36, and all I need to do is to cross multiply to get AC, 30.5. Alright, so AC is 30.5 meters. Moving on to part B. Okay, so we already found AC over here, and the question wants us to find the perimeter ABC. So the only thing we are lacking of is AB, right? So there are two ways to do it. Either you do it in the Pythagoras theorem way, or you can still stick to your Tuakaso. So this is the A, this is the H. So you can make use of cosine 58 equals to AB over BC, cross multiply to get AB, and then put them together as your perimeter. So like I said over here, Pythagoras theorem can work too. So you can use these two values that you already have, do Pythagoras theorem to find the length of AB, and you will be able to get 85.6 meters for the total perimeter. Moving on to part C. Okay, we have a bearings question over here. I mean, if they give us a north line, chances are it's going to lead to that. So we have the north line over here at B. And the very important thing about bearings is that we must know where we are measuring the bearing from and to where. So where's the origin? Okay, and then where is the endpoint, right? Or you can call it like the source and the endpoint. So from here, B, the point D is a bearing of 116 from B. So number one, bearing is measured from the north line and going clockwise. So over here we can see that 116 degrees is roughly over here, right? Clockwise, it has to be more than 90 degrees for sure, and then somewhere over here. Doesn't really matter how much of the angle you are cutting, but we do know it's more than 90 degrees. Okay, so I can draw another north line over here and name it N2. Why I want to do it this way? Because D is somewhere over here, right? This is where D is. And the question wants us to find the bearing of B from D. So from D, at the north line, we draw clockwise until it touches the line joining B. So now we're going to ask ourselves, how do we find this angle? And one very important feature for north lines is that we can use them as parallel lines. And parallel lines over here, we can think about it as interior angles. That's the most commonly used one in bearings. So if both of them are the parallel lines, that means I can say that the interior angles over here will add up to 180. So I will easily find 64 degrees by taking 180 minus 116 here. So 64 degrees is over here. Okay, and this is super important for you to find the remaining angle, right? So by using the property of angles at a point, we will be able to take 360 minus 64, which gives us 296 degrees. Okay, and that's our final answer for the bearing question. Next up, we have cumulative frequency curves. So for cumulative frequency curve, right, firstly, always observe where this curve is ending at. It may not necessarily be the final line here. Just take note, okay? Because this represents the number of people. So if we actually interpret wrongly the number of people over here or the total number, it is going to affect your data calculation in the next few steps. Okay, and of course, observe what is this, what does this represent, and what's the scale like. So let's take a look at what the question is first asking. Part A says, use the diagram to find the interquartile range. Interquartile range is equals to upper quartile minus lower quartile. In order for you to find upper quartile, as what we have gone through in the earlier question, upper quartile is the 75% of the frequency. So we will have to find 75% of the total number of people here, which gives us 60. And from here, we're going to join 60 all the way to the curve because you need the mass. And we'll get the number later on. Okay, so that's number one, upper quartile. Next, we also need to find the lower quartile, which is the 25% of the frequency. So that's going to give us 20. Do the same thing. Draw it to the curve, from the curve downwards, and we will have upper quartile to be 235 and lower quartile to be 150. And putting these two together will allow us to get our Q3 minus Q1, which is 235 minus 150, and with a final answer of 85 reps. Okay, right? So this is usually the technique we use for when it comes to cumulative frequency curve. Moving on to part B, it says one of these people is chosen at random. The probability that the person's estimate is greater than this amount. So take a look, the mass is right now. The bigger masses are here, right? So greater than, we know that it's going towards this direction. So 2/5, the probability that this person's estimate is greater than this mass is 2/5. So first, we need to go and find out the number of people to be greater than this kilograms first. And 2/5 of the entire cohort or the number of people is 2/5 times 80, and that's 32. But here's a very important thing when it comes to cumulative frequency curve. When we read questions like this, right, we know if it's on the top half, okay, I can't say top half, but if it's on top of the curve, we can't just go and find the value 32. We want to count backwards from 80, because we need this portion more than the weight, right? We need the 32 people here. We don't want the 32 people at this range. So when we minus 32, the value is actually 48 here. So you can see my green line, I actually went back down here, and that gives us K to be 220 grams here as our final answer. So if you misinterpreted it and you put 32, you are actually finding the number of people being less than the weight, 32 people. All right, it will be this part right here. Okay, so please read the question carefully. Next up, for question 12, we have the making the subject formula, right? But the very first part, part A, just requires us to sub in the required value. So here we have A, B, and C. Okay, so we can just put in the values over here. All right, and one very important thing, okay, is to ask yourself, where does this square belong to? So this square over here, right, actually is only with C. If it's with B, there should be a bracket right here. Okay, so that's one very important thing you have to take note when it comes to squaring things. So make sure when you type into the calculator, 0.361, okay, is the only one that's being squared, and then you'll be able to get a value of 2.980, and rounding up to 2SF, it should give a 3.0. Okay, now we start the actual making something the subject. Whenever there's making something the subject in a fraction aspect, right, I always tell my students, we try to make all the denominators the same first. And why is that so? Because in the context of equations, when we make everything the same subject, only in an equation, let me just specify, only in an equation, we are allowed to remove them. So now, since every single fraction has a denominator of b, I will be able to cancel that. Okay, because it's easier to deal with terms that are not fractions. Okay, that's my method usually. Next, it's not over yet. This is not our final answer. We are supposed to make C the subject, right? So over here, we try to shift those with C to the left hand side first. Okay, so from dB equals to A equals to B square C square, the only term that with C square is this. So I'll shift it over here. Next, divide the terms that are not C over. So B square is 1 that we need to divide over. So it gives us this right here. A lot of students, they tend to have a bit of problem knowing when to divide, when to times. So I always like to bring in like normal numbers, right? For example, I can say that 2 times 3. 2 times 3 gives me 6, right? This is a known fact. So naturally, I can also say in order for me to get 2, I need to take 6 divide by 3. So this is actually literally what you are doing for this question. You have this right here. It's like 2 times 3 equals to 6. So all you have to do is to get 2, you divide 3 over to get this part right here. But of course, this is not your final answer. You still have to remove your square by putting a square root, and then you have your plus minus. Alright, so you have the plus minus right here. Please put a plus minus, okay? Very important every time we square root stuff, and that's going to be your final answer. But before we insert it into the blanks, always just check one more time. You only have your subject on one side, and you have other things on the other side except your subject. Okay, and if all is good, then we will be able to fill it in. Okay, not sure why I got double over here. Okay, so please ignore this. You can just insert it over here. Alright, okay, we're going to move on to question 13 on properties of circle. Right, so we have A, B, C are points on the circle with center O. Okay, and they give us all these values over here. The very first part is to ask us to find angle OBC. Angle OBC is over here. Okay. And before we start the question, one very important thing for properties of circle question, which I always encourage my students to do, is to go and identify two things. At least these two things. Do we have a diameter? And do we have a radius of the circle? Okay, so we can see that I do have a diameter, CA. In fact, if you have a diameter, you also know what are the radius. OC and OA are also the radius of the circle. But there's more radius also. OB is also a radius. And of course, OA. Okay, why did I specifically point out these two? Because usually when we can find radius, right, I will be able to identify an isosceles triangle. That's one. Next, when I can have a diameter, I can use the property of the angles in a semicircle, right angle in a semicircle. And these are the two things that you really need for this question, in fact. So for angle OBA, we can straight away say that it's 28 degrees here because of base angles of isosceles triangle. That's one. I can also say angle CBA is 90 degree, and that's because of right angle triangle in a semicircle. And with the help of these two, right, I naturally can just take 90 minus 28, because this entire thing is 90, this is 28, and this was the angle we want to give us 62 degrees over here. Okay? Right, so that's for part A. Moving on to part B, explain why DC is not a tangent to the circle. When we think about tangent, especially in the case of properties of circle, the one thing we want to think of is radius perpendicular to tangent, right? So radius perpendicular to tangent is this and this. Radius perpendicular to tangent has to be 90 degrees. And we can easily do a calculation over here. Okay, so for this calculation, what we can do is to take our 180, right? So we can see that there's a right angle triangle right here, right? So in order to find my angle, okay, I can't call it right angle triangle. We can see there's a triangle right here, and we can find the angle over here because I already have 60 degrees and 28 degrees, right? So if you take 180, okay, my numbers went missing, so I'm going to write it down. Minus 60 minus 28, right? So when we do sum of angles of the triangle itself, 180 minus 60 minus 28 is going to give you 92 degrees, right? And 92 degrees, of course, is not equals to your 90 degrees over here. So please add this into your working, right? And since it's not 90 degree, then according to the property of radius perpendicular to tangent, DC is not a tangent to the circle because OC is not perpendicular to DC. Alright, okay, so yeah, take note of this part. Question 14 is on simultaneous equation, and for simultaneous equation we usually fall back on two things, either the substitution method or the elimination method. So between these two, usually I will tend to see, do I have any 1x or 1y? If I have any single 1x or 1y, it will be easy for me to make one the subject and do a substitution without a fraction. Okay, but right now, because I have like 6, 5, 10 and 4 over here, I will rather do elimination method just to make one of them the same. Okay, so in my case, I'm going to make y the same now with 5 and 4 over here. Okay, so I'm going to take equation 1 and multiply by 4 to name it equation 3. I'm going to multiply by 5 for equation number 2 and make it equation 4. So between these two, every time when we do elimination method, we have to really check the sign. What are they opposite? Are they the same? So since they are the opposite, in order to eliminate them, I need to take equation 3 plus equation 4. So that will have like a 20 minus 20 over here. And the addition of these two will allow us to have this plus this equals to 8 plus 3 to 5. Okay, so 20y is gone and I'm left with 74x equals to 333. And I'll be able to solve for x. And with the value of x, I will be able to sub it in to find my value of y. Okay, so we have it over here. X is equals to 4.5, y is equals to -5. Next up, we have quadrilaterals. Okay, so this question 15, very interesting. Usually they don't really just show you one quadrilateral over here and ask you to find it. We have a trapezium right here. Okay, and then that's when you have to think about what are the properties of trapezium. Okay, when you start this question. So ABCD is a trapezium, and we have the ratio of angle CBA, BAD, and ADC to be 9:3:2. And we want to find the angle of BCD. So, firstly, trapezium has a pair of parallel lines. Can you see that they have tested us these parallel lines a second time already for the interior angles? Okay, so take note, the properties of your angles over here, these interior angles, okay, is useful in many places over here. So right here, we are actually looking at the interior angles because we have a pair. Every trapezium has a pair of parallel lines. So between the two parallel lines, I will be able to form 180 degrees for the sum. So between these two, since they add up to 180 degrees, we know what 9 plus 3 consists of. Because it's 9 units and 3 units adding up to 180 degrees. So we'll be able to find one unit to get 15 degrees over here, and proceed on to find ADC, which is 30 degrees right here. Why is this part important? Because remember, you still have your parallel lines. So this two angle over here is going to also add up to 180. So let me color code with another color. Yeah, another color over here. This angle plus this angle, because it's between two parallel lines, is going to add up to 180 degrees. So I can take 180 minus 30 to get 150 degrees as my final answer here. Okay. On to the next question on compound interest. So this person named Alice invested some money into an account paying compound interest at 3.2% per year. After 5 years, the money had earned a total interest of this amount. Calculate the amount of money Alice invested in the account. Okay, so let's talk about the formula that we have on the formula sheet first, the compound interest formula. It looks like this. What does each term represent? So firstly, for our P itself, we have the, this thing not popping up. Hold on. The P itself, we have the principal value. Right? P itself is the principal value, and that is the amount of money invested into the account. R itself is the interest per time period. So it depends on, are you applying the interest in years, in months, twice a year, whichever. It depends on the question. N is also dependent on the question. Number of times being compounded. So are you doing every single month, or are you doing every single year? So it has to work hand in hand with your value of R. Okay, so, and most importantly, and for this question especially, this formula comprises of the principal amount along with your interest earned. So remember, compound interest formula includes the money you just put in plus how much you earn. Alright, so let's go back to the question now. Alice invested some money into an account, okay? And we have this. So the sum money represents your principal amount. Compound interest at 3.2% per year. So this 3.2 is your value of R. After 5 years, can you see the time period is popping up already? N. The money had earned total interest. So take note, this amount is only the interest, not the principal value. And eventually, they want us to calculate the amount of money Alice invested in the account. Okay, So, since interest is $2,132.16, to find interest with the actual formula sheet, right? Actual formula in the formula sheet, we have to take the entire thing minus off your principal amount. Okay, right? So we can also say that this will represent this. And let's submit the values now. And we have R equals to 3.2. This is in a yearly basis, 3.2%. And we also have N equals to 5. Again, it matches. Alright, so that's a very important thing. Make sure the interest given fits the time period. So all of these are in years now. So we are good to go. So moving on, putting the values in, I will have 3.2 here, 5 here. And what you should notice is that this actually forms a value for you already. So you can actually type this into your calculator to get 1.17057. And you can see it's actually just an algebraic equation. Okay, so just proceed on to find P and you will get $12,500 to the nearest dollar. Next, we have a Venn diagram question, question 17. So this Venn diagram question is actually rather interesting because the first statement is actually super important. Let's take a look at what it is. The Venn diagram shows the universal set. Okay, of course, it's the entire set right here, and the number of elements in each of its subsets. So many times when we look at a Venn diagram question, when they give us a Venn diagram, the things inside that we see, right, are usually the elements. But for this question itself, they actually give us the number of elements, which means there are 9 elements here, there are 7 elements here, 3 and 6 elements respectively. It's not element 7 or element 3, not that. Okay, so really have to pay very close attention. Don't assume that it's always elements. All right, read the statement first and then start your question. So the very first thing, they want us to find the value of this one right here. Okay, it looks a bit scary, right? But let's dissect the notation together. Okay, so firstly, we have the N in front. This N in front, by the notation itself, we understand it to be the number of terms or the number of elements. Next, we want to find where both of them have in common. So this intersection over here, okay, it means intersect. We want to find what this and this have in common. So usually I teach my students this method, the ticking method. So I'm going to give the green tick, okay, to this one over here. And why is A prime union B? A prime union B is those not in A together with what I have in B, right? So this is what we have. Okay, so this is my B. These two ticks are for the B, and A prime is the one outside of A right here. Okay, so these are my areas for this first part. Second part, I want A union B prime. So A union B prime, we're going to use a orange tick. A union B prime, okay, these two parts are A. B prime is here. So, since we want to find where both have in common, you need to find the areas with both colored ticks. And we have 3 and 9. So in total, we have 12 elements for this entire thing. Now let's take a look at part B. Okay, so for part B, they changed it a little bit. Still number of terms or number of elements. But this time round, we want to find union. So we're going to add every single thing. Union, another word for unite. Okay, unite together. So we can use the same color for everything. Alright, so let's find out where is A intersect B prime first. A intersect B prime is here. Okay, A union B whole thing prime. That means I want everything outside of A union B will be here. And because of the word union, right? you will be able to see that we are taking all the areas with ticks. It doesn't matter we have two color, one color ticks, no, because we are uniting everyone together. Whoever that has the ticks, we take them, and then we have this as our final answer. Alright, let's move on to question 18 on standard form. So part A says write 263 in standard form. Okay, and in order for us to know when something is in standard form, it must always be in this form, right? And A itself is very strict in the sense we have to make sure it's between 1 to 10, less than 10. So the maximum value you can actually have is 9. Okay, which also means the digit in front of the decimal can only be one digit, a single digit over here. So if we think about our decimal place over here, that means, right, it's going to move 1, 2. Okay, so usually how I think about it is if the decimal shifts back by 2, okay, that's the number of placing it must go, the n will go up by 2. Right, so I'll explain further on how this happens in the next part as well. But for part A itself, we have 2.63 times 10 to the power 2 as our final answer. Okay, so for B part 1, write 3.4 times 10 to the power 99 in the form A times 10 to the power 100. So let me repeat what I was just talking about in part A. The dot and the power part, right, they always behave in opposite direction. That's something we can think about. So if the power adds up, go up, our dot moves back in that same number. If the power go down by 1, then our dot going to move forward. So in this case, right, originally the dot was over here. It shifted back by 1. Why is that so? Because you wanted to up from 99 to 100. So if you up by 1 over here, means you must go down by 1 in terms of the dot. So that's one way you can think about the arrangement of the dots as well as the power. Okay, so the final answer is going to be 0.34 times 10 to the power of 100. And this is going to help you with part 2 because they want us to solve 4.7 times 10 to the power 100 plus 3.4 times 10 to the power 99. And the thing about addition and subtraction of standard forms is that if these two are the same, we can add it up very easily. So that's why I say part 1 is going to be very important. So we could actually change this straight away to 0.34. And after which you can see both of them are the same. You can think about it like an algebra like that, like 4.7a plus 0.34a. We can just easily add it up to give us 5.04 times 10 to the power 100. Okay, so 4.7 plus 0.34 will give you this number here. Moving on to question 19 on HCF and LCM. Written as a product of its prime factors, 720 is equals to 2 to the power 4 times 3 squared times 5. Okay, and for this HCF and LCM question, we are supposed to kind of work backwards because we are given the HCF as well as the LCM. How we can do this is to consider HCF's requirement. Usually when it comes to HCF, we take what both of them have in common. And when they both have in common, we always take the smaller power. So we do know that both 720 and n definitely have factors 2 and 5. Okay, so that's what you can put right here first. Next, LCM is the case where we take all. We take all the factors, and if they are in common, we take the bigger power, right? Which means that we know 2, 3, and 5 will exist somewhere. So as we compare these two, right, we will know that, hey, where's 2 to the power 6? We must have 2 to the power 6 somewhere, right? So since 720 has 2 to the power 4 already, 2 to the power 6 definitely belongs to n. And 3 square it already exists over here and it didn't appear in HCF, so you cannot add a 3 right here. And lastly, there's we don't have 5 to the power of 3 yet. Okay, 720 only has 5. So n definitely must have 5 to the power of 3. And then we have our answer. We can put this together as 8,000 here. Alright. Okay, we're going to move on to question 20 now on trigonometry. So the question is quite short. They just gave us sine 2x equals to 0.561 and we need two possible values. This two possible values question is quite common, right? And we just need to consider two things, the acute part as well as obtuse part. So when I actually continue on, one way for you to think about it is also, since the range of values is from 0 to 90 and the question currently is 2x, we can also think about it as the times 2 of it. We have to consider 0 all the way until 180. So one more reminder is they also put it here, the degree, and 0 to 90 also means is degree mode. Okay, and why is that important is because you must make sure you change your mode in the calculator to degree mode when trigo is in the picture. Only if trigo is in the picture, then your radian and degree mode in the calculator matters. Okay, so we're going to shift the sign over to the right hand side. Okay, so 2x is equals to sine inverse 0.561. Alright, and upon doing the inverse, I will be able to get 34.125 as well as 180 minus 34.125, because remember, you need two possible values. Okay, so this range allows us to have the acute angle and the obtuse angle over here, which gives us the value of 17.1 degrees and 72.9 degrees for your two final answers. Moving on to question 21 on stats. So this statistic question it actually comprises of a series of numbers here and two unknowns over here, 2p and 4p squared. It represents the text messages by D over 8 days. And one very important information for part A is that the mean number of text messages per day is 17.5. So you just need to think about the normal mean calculation, because it's an ungrouped data, right? So all we have to do is to add all of them up together, divide it by 8, okay, all right, amongst the 8 days, equate it to 17.5. Okay, then that's when we can cross multiply to have our value right here. And because as you can see, we have a p square over here, right? That means we have a quadratic equation. So when it comes to quadratic equation, we shift every term to one side so that we can solve for p right here. So I have p to be equals to 5 over 2 or negative 3. But here's the thing, the question only says p is equal to 2.5, so we must find a good reason why we have to reject p equals to negative 3. So in the context of this question, we are talking about text messages, right? So there's no way for text messages to be negative 6. Yeah, if I take 2 times negative 3. So just write down there, rejected as p is more than 0. Okay, moving on to part B. So part B, right now, they gave us the standard deviation of Lee. They also gave us the information about Lee's sister, and that is the mean for Lee's sister in terms of text messages is 20 and standard deviation is 9.51. So it's a very, I would say, quite a common question for mean and standard deviation. They like us to give comments about the means and the standard deviation over here. So we can first talk about the mean, right? So number one, Lee and Lee's sister has mean 17.5 and 20 respectively, right? And mean usually refers to the magnitude. We can compare, someone is faster, heavier, has more of this, less of that. We can use mean. So Lee's sister received more messages than Lee, okay, as the mean of messages is much higher, right? 20 and 17.5. And for the standard deviation, Lee is 7.89 and Lee's sister is 9.51. So between these two, I can actually talk about consistency. So when it comes to standard deviation, just a bit of recap, right? Standard deviation is the average, it's the spread from the mean itself. So the smaller the standard deviation, that means your data are closer to the mean. And if they are closer to the mean, they are more consistent. Okay, so in this case, Lee received the messages Lee received is more consistent because it's smaller than Lee's sister, as the standard deviation is lower. Right? Question 22 is algebra rainbow expansion over here. Okay, but the difference for this is there are 2 terms for the first one and there are 3 terms for the second one. So the rainbow is not just the usual 4. We are looking at 1, 2, 3, 4, 5, 6. 6 rainbows over here. Okay, so we can put them together. In this case, these are my blue rainbows and these are my red rainbows. Okay, so be sure to check every single term and carefully expand each of them. Upon expansion, put all the like terms together. Okay, so we have our x squares and x that can be combined together to give us this answer right here. Alright, so for this one, I can just tell you all, just really need to be extra careful with the expansion. Is a, I would say, easy mark to get as long as you are careful. Alright, moving on to question 3 on Pythagoras theorem and algebra. Okay, so we are given this right angle triangle with 3 different dimensions in x and y. And the question says, show that y is an odd number. Pretty weird way of phrasing. Usually when it comes to Pythagoras theorem or any geometry, we just need to go and find a missing side, that kind. But this time around, they actually link it to the arithmetic side of proving it to be an odd number. Okay, so let's dive deeper into it. The only information we can kind of form right now is because it's a right angle triangle, so I will be able to form my 3x minus 1 square plus y square equals to 3x plus 4 whole thing square. And since our job is to show that y is an odd number, then I'm going to proceed on to make y the subject first. Okay, so I proceed on to expand this and make y square the subject. Okay, of course, the ultimate goal is y, but since I have y square first, let's think about what is y square comprised of. So y square itself, we have 30x plus 15, right? And one very good feature you can do is to do a factorization. Okay, I'll be able to factorize it to 15 times 2x plus 1. And you may be wondering, why do we even need to do this? How come I need to go and factorize and see these two? Because there are some terms where you can see exactly whether they are odd or even. Like in this case, I will be able to see that if 15 is an odd number, right? 2x plus 1. 2x itself is always an even number. 2 times any number is always even. So whenever I add a 1, it changes it to odd. So what is the result of 2 odd numbers multiplying each other? The answer is an odd number, right? So no matter what, y square is an odd number. So this is a very important thing you have to take note of on how the multiplication of odd and even numbers, right? What does it give you? And because of this, since I know y square is an odd number and y square comprises of y times y, in order for you to get an odd number, I need y to be an odd number. Okay, but of course we cannot just draw so many arrows as your final answer. So let's put them together in words, right? So for any integer x, we're going to start from here. 2x is an even number. So from here, after this stage, you can jump to here. 2x is an even number. 2x plus 1 is an odd number. So it makes, right, the multiplication of the odd times odd to give you odd number here. Next, hence, y square is always odd, right? So because y square is equal to 15 times 2x plus 1. So there's no need for you to go and explain that. Now, if y square is an odd number, and all odd numbers consist of odd times odd, then we can straight away conclude that y has to be an odd number. Proven. Okay, alright, so we still have to start from the Pythagoras theorem part, but after that, eventually you have to think about the arithmetic side. How to get an odd number? What does an odd number comprise of? Okay, what multiplied by what will give me an odd number? All these things will be very important. Next, part B. Find a possible value of y and the corresponding value of x. So, possible value of y, we do know now that y has to be an odd number. So for any odd number you throw in, you should be able to get your answer already, right? So in this case, I'm going to let y to be equals to 15. I'm going to insert it into our y square equals to 15 times 2x plus 1, because this allows us to find x as the answer. Okay, so as I shift it around, x will give you 7, which means x will be equals to 7 while y is equals to 15. Okay, these are our two answers. So for this one, there's a combination of many possible values right here. Okay, as long as you make sure y is an odd number. Question 24 is on algebraic fractions. Okay, and one thing about algebraic fractions over here is also looking at how to simplify them, right? So every time we look at algebraic fractions, the first thinking is that, oh, you know, can I cancel things? Will I be able to reduce it much more? But here's the thing, one very important thing before you start cancellation is that it can only happen when we have fully factorized the numerator and denominator. Okay, and you take a look at this current portion, is that they are not factorized at all. Every term are on its own. 3x squared, x, 6x, x to the power 4, minus 16. Okay, so make sure we settle that first before you start the cancellation. And the next question will be, then what factorization method do we use? So let's take a look at the numerator first. Numerator, the maximum thing we can do is to sub out the common factor. Okay. However, for the denominator, it's our good old friend. Okay, it's something that is very highly tested, and once you can spot them easily, right? Okay, it's going to help you overcome a lot of question types right here. So you're going to look out for two terms, a minus sign and perfect square. Perfect square. Why is it perfect square? Because it's 1 here and 16 over here. So we can straight away turn to our a square minus b square here. Okay, so let's start our factorization over here. Okay, so in this case, okay, let me put out everything first. In this case, we can put it as 3x times x plus 2. Okay, and at the bottom, one thing you can actually do first is x square minus 4 whole thing square. Alright, and that allows you to factorize it to x square minus 4, x square plus 4. But here's the thing, when you stare at this fraction right here, you'll be thinking, usually when it comes to simplification, there should be terms to cancel, but at this point we don't have any terms that we can cancel, you know. Okay, there's nothing that look alike. So that's when I circle this part over here. We have to take note of this one because we have two terms, minus sign and perfect square. So there's actually further factorization we can do for this part, and that's when we can make it to x minus 2, x plus 2, which allows us to cancel. Yay, we actually got two of the same terms right here, so we can cancel it off and we'll be able to get this as our final answer. Moving on to question 5, we have solving by completing the square. Okay, this is actually, I would say, a very, very common question, and something that we can really, it's an easy 3 marks you can get as long as you follow the rules. The question says complete the square, solve by complete the square. So don't go solve by quadratic formula or calculator method. Once you do this, you will not get your marks. Alright, so firstly, we need to change this to the completed square form. Okay, I love to start off with the bracket square minus bracket square, and I always know that this number and this number will be the same. That's how I usually start completing the square. And of course, the plus 17 always follows through. And then we can combine the two numbers at the end to give us negative 19 here. So the very next step determines that you are really using completing the square. One very common mistake that students make is they tend to expand it out again. But when you expand it out, you get back to the first part. Then what for we do completing the square, right? So what's special about completing the square in terms of the next step is we will do a shifting of negative 19 to the right hand side. Okay, sorry, there's a double of this, ignore this. And then we will square root 19 because we want to remove the square here and find x. Okay, so we are slowly peeling the onion like that. So we are removing the square over here by doing a square root, and please remember to include plus minus because we have two possible answers. Next, we'll be able to shift 6 over, and then that's when we have two answers over here, one with the plus minus, and we'll get 1.64 and 10.36 to 2 decimal places. And one very important tip is that in order to check whether your answers are correct, just use your calculator and see if it gives you the same answer. Okay, if it gives you the same answer, that means all good, you're on the right track. Okay, your calculator will be the accurate one. Just to tell you, if you type everything correctly, calculator will be the correct answer in the event if there's something off. All right, moving on to question 26a first. Okay, 26a itself, we have one diagram, B has a separate diagram. Okay, so that's why I want to specifically put this one over here. And for A, we are focusing more on the mensuration aspect. So this question gave us a cone and a cylinder with the dimensions that's given to us right here. They already label it for us. So one very important information here is that the container is half full of water. All right, and the first part of the question wants us to find H. So since we know that this container is half filled with water, I can easily say that the volume of cylinder is equals to the volume of the cone. So that's where we can fall back on our formula sheet, because we do have the formula volume of cone on the formula sheet, 1/3 pi r square h. Okay. However, we do not have the volume of cylinder, but one hack you can think of is it is the volume of the cone without the 1/3. That's the volume of cylinder. So we have these two things right here, and both sides involves your pi r square, right? So that's when we can cancel them off, and in order to find h, we take 20 divided by 1/3 to get 60 cm here. Okay, so that's our answer for part A. Moving on to part B. Part B has a combination of two things. Still your mensuration, that's important, and the concept of similar triangles. So let's take a look at this diagram right now. This diagram, the difference is of course the dimensions, that's number one. And number two is that now your water level actually rolls up a little bit to this point. But the container is still half full. So they actually want us to find the value of D as well. Okay, they want us to find the value of D. So by looking at this, right, one thing, every time when we see such a diagram, one very important thing is to see them in a similar triangle form this way. Okay, and you can see I introduce my own unknown over here, this R, which we try our best not to involve it too much because it's our own unknown. Okay, however, we need it because we need to find the volume of this later on. Okay, so by using similar triangles, okay, we can say that D over 90, so that's the ratio of this triangle and this triangle on the side, is equals to R over 10. So I'll be able to say that R equals to D over 9. That's the proportion we can use along to move forward to the next part. So let's see what we can do. Since it's half full, we can say that the rate volume is equals to the blue volume as indicated over here. Okay, and what do we have for the red one? Is like a mini cone. It's a small cone, then this one is the bigger cone, right? So the red volume is 1/3 pi r square, so we had r over here, h, while the blue side has two parts. One is the cylinder and the other one is the frustum. The frustum just means the portion of the cone right there. So we need to take the big cone minus the small cone, which is what's happening over here. And across the board, it may look very complicated at first, but we can divide every term by pi. You can see every term has a pi over here. And we're going to proceed on to sub in our similar triangle ratio here of r equals to d over 9. Because r is something we form on our own. Let's not use r already, okay? But because of that, you will be able to find the value of d. Because simplifying this, I will be able to get d cubed over 243 equals to 5,500 minus d cubed over 243. Shifting this term to the left gives us this, and we can proceed on to divide 5,500 divided by 2 over 243 to have this value right here. And finally, to find d, we cube root to get 87.4 as our final answer. We are on to our last question on vectors. Okay, so we have this diagram right here for us. OAB is a triangle. C is a point on BA such that BC to CA is 2:1. Okay, so I've indicated this over here. We have OA, we have OB, and we are supposed to find position vector OC. So take a look. When it comes to vectors, I always tell my students, we think about it as ourselves doing a walk from one point to another. So if I want to find OC, it's like us walking from home to school. What are the other routes I can take to walk from home to school? Because the thing is, we have no information here. We want to try to walk on routes where we are familiar with, that we have. So one possibility is walking from O to B, so maybe from my home to the shopping mall, then from the shopping mall to the school. Okay, that's one. Or I can also walk from my home to maybe the gym, and then walk to the school. Okay, so something like this. And that's when we can see that in order for you to walk either this way or this way, you first need this vector. So BA comes into the picture, and BA is walking from here to here, here to here, and visually we can see that I can walk this way and this way, which is BO plus OA. BO itself is against the 6B. You can see that it's going opposite direction because OB is 6B, right? So BO is going to be negative 6B, while OA is 3A over here. Okay, so we can add these two up to have this vector over here. And finally, you can either use AC or BC to continue your route. In my case, I use BC. BC is 2/3 of BA, so I'll be able to times it in to get minus 4B plus 2A, and then we can finally do our long walk. So this is like a shortcut, then it's like a longer path to get to school, right? So my OC is going to be OB plus BC, which is 6B plus this, to give us 2A plus 2B here. Okay. Next part of the question is a little bit more complicated. All right, we have P being the midpoint of OC, and Q is a point on OB such that APQ is a straight line. Okay, visually we can see it as well. AQ is a certain multiple of AP. Makes sense, right? Because they're collinear. OQ is also a certain multiple of OB. Also makes sense because they are also collinear. So ultimately, they want us to find the ratio of OQ and QB. And actually, if you know what is N, it makes this a lot easier. So we can try to expand a little bit more on these two vector relationship that we have. Okay, but the very first thing we can use is actually my midpoint. Since P is a midpoint, 1:1, then I can say that OP is half of OC. We found OC in the previous part, which is 2A plus 2B. So we can cut it into 2 to have A plus B over here. Okay, why is that important? Right now, we're going to take a look at this AQ equals to MAP first. And this can be divided further, okay, or simplified further into OQ minus OA. Okay, our standard vector, subtraction. And AP can also be changed to OP minus OA. Why do we want to do that? Because we do have the value of OA, OP, OA here. So I'll be able to first change this to 3A and shift it to the right hand side. That's why I have this term here. And change OP to A plus B, and of course OA to 3A right here. And we will be able to form a combination of A. So I rearrange and put the A together. Remember, M is a number and B here. Okay, so why do we need this? Because we actually have another relationship of OQ. OQ is equals to NOB, right? And that means, and we do have OB, so we can say that OQ is equals to N6B or 6NB, whichever, right? And can you see that now we have two equations involving OQ? So by right, since both are OQ, this is supposed to be the same as this. That allows us to compare coefficients. I will be able to put this on the left hand side and compare with this one, and you will see that I actually put a 0A over here. Why? Because I just want you all to see see easily that comparison. I'll be able to compare this with the 0 because both of them has A. So 3 minus 2m is equal to 0, which means m is equal to 3 over 2. And because for B itself, n is equal to 6n, I will also be able to submit over here to get n equals to 1/4. But that's not it. The question is not asking for m or n. The question is asking for ratio of OQ to QB. So when I sub it back in, right, we know that OQ is actually equals to 1/4 of OB. OQ is 1/4 of OB, which also means OQ is going to be 1 unit, while QB is going to be 3 units. Then we can insert our ratio over here. On to the final part. We are given that the area of triangle OBC is 25 cm square, and the question wants us to find area of OAC. Every time when we are looking at vectors with area of triangle, we want to consider either one of these two things. They are either similar triangles or they both share the same perpendicular height. So for this one, because it's OBC and OAC, okay, you must have the ability to flip the triangle around or be able to identify the base. We can actually see that this triangle, both of them share a common right perpendicular height right here. See, OBC, I can say half times base times height. OAC, half times base times height. Okay, and it's easier to use these two because we already have the two ratios right here. How come we can use same height? Because we want to link it to our half times base times height. The half times base times height allow us to cancel the half and the h while inserting our BC and AC with the ratios that we have. And this can easily help us to find the ratio. This is not the actual number. This is the ratio of triangle OBC is to triangle OAC. So since area of OBC is 25 cm square, To find OAC, we can easily divide by 2 to get our final value of 12.5 cm squared. So that's all for paper 1. If you want videos like this, subscribe, drop a like, and leave a comment on which question you want me to break down next. I'll see you in the next one.